new alewife. So I've learned something I have to share with you guys. Sometimes the best way to start dialogue is to say something that is so incorrect. So the title of the talk, Goby the New Alewife, should kind of move you a little bit, but I'll share a personal story. I have a couple teenagers, and teenagers oftentimes will be on their phones. They don't pay attention. It's hard to get them in dialogue, and all you have to do is say something like, isn't there like a really cool game called Candy Crush? And oh my gosh, what are you talking about? The Clash of Clans, and they'll start telling you every game that's cool. The next thing you know, they're talking. Well, that little lesson, and they might even stop texting, but that lesson of saying something wrong to start dialogue, I found actually works on tech committees too. So, Goby's the new alewife. What do we mean by that? Well, the tech committee, go ahead and, I have the clicker. We got a whole bunch of people started talking when we said, maybe Gobies are replacing alewife as a major forage fish in Lake Michigan. And what interested me about saying that was not only the amount of involvement across the people, but also the agencies from the National Park Service, USGS, Central Michigan University, the LMC's program, the Nature Conservancy, UW, Milwaukee. A lot of people contributed data to this talk, and I think the dialogue will continue to go because I'm going to say a lot of things in here that I think most of you will probably disagree with. Hopefully that starts dialogue. But if you saw Bo's talk yesterday about the forage fish surveys, what you found was that the forage base is down. And there's a lot of concern about the predator-prey ratio, the amount of predator base out there relative to our forage levels, so reason for concern. But if you look at the diets of predators in Lake Michigan, almost every single predator has gobies in their stomach. Matter of fact, when we first started the dialogue at the tech committee a couple meetings ago, I said, if you do any diet studies, raise your hand. And most of the group raised their hand. I said, what species do you see gobies in? And it was everything from yellow perch to ciscos to lake sturgeon to lake trout, you name it. So how can all these predators be eating gobies, but yet the forage base is down? And how many gobies are in Lake Michigan? A simple question. Well, we found that actually that's a very difficult question to estimate how many gobies are in Lake Michigan because they have some unique behavior and habitat preferences. And I'm going to show you some of those today. But just a simple question, how many gobies are in Lake Michigan can be difficult to address. So we kind of put some stuff out there at the Winter Tech Committee, at the Summer Lake Michigan Tech Committee about how important this is. Our ability to estimate gobies as probably the second, if not top forage fish in Lake Michigan, and the idea that we're uncertain on their importance or their absolute abundance. And so it was a great discussion. Unfortunately, I missed the Winter Tech Committee meeting, so that's why I'm here today is they assigned me this presentation and topic. So that's what happens when you miss a tech committee too. So I want to start by saying, well, what do we know about round gobies? And if you're here for the Michigan session yesterday, what you saw was that the USGS presented their bottom trawl survey estimate, so let's look at that. This was in the Status Lake Michigan Forage Fish Report, and I think there's a report outside on the desk as well. And basically what you saw is a trend starting with no gobies, the invasion, and an increase, but then also a decrease, lake-wide estimate around 2 kilotons, I believe. So this in context of alewife at 9 kilotons, the forage base is down, also declining trend of gobies, but some variation. So is that the answer? Are there 2 kilotons of gobies Lake Michigan? Well, I believe Bo also said, well, round goby is one species that we are not at a record low, and it's kind of known that the biomass estimates from these bottom trawl surveys might be biased. Maybe there's more gobies out there than what we think. Maybe more than 2 kilotons. So, we'll deal with it now. All right, so nearshore trawling. How are we going to deal with this? Well, the one thing I want to point out is the 2 kiloton average from the bottom trawl survey is derived from water depths of 5 to 114 meters in Lake Michigan. In other words, that's the amount of area the bottom trawl is characterizing 2 kilotons of gobies. But there's other trawling done in the lake by various agencies, many of the people I listed in the first part of the presentation. What if we added those nearshore trawls? The trawls very shallow depths. in other areas close to drowned river mouths. Would our estimate of 2 kilotons go up or down? Well, let's try it. So I pulled in the Inland Seas program, Michigan DNR Trawl Series. I didn't have a chance to pull these in, but I think this is the next step. Bring in some of the nearshore work. We know there's a lot going on in the nearshore. So if we use those estimates, can we add them to the bottom trawl and add to this shallow depth less than 5 meters? So let's start with the Inland Seas program. The Inland Seas program is a great program. It's an educational-based program in Grand Traverse Bay. But they have a long series of monitoring. They had 800 and some trawls to pull from over the course of in Grand Traverse Bay. It's a phenomenal data set. This is a small trawl. Okay, the USGS bottom trawl is 3 times the size, and it's in nearshore, shallow waters. Their average depth is 7.5 meters, but they trawl as shallow as 3 meters, similar to some of the other nearshore trawling you'll see. So what we did is we basically took their estimates, and they're originally, what I should also say is, I'm not going to deal with the seasonal component of some of these data. I'm just going to average all of the data. But I also think when you look at round gobies and the challenge to estimating round goby abundance is going to be, there's also huge seasonal components to their movement. But let's just average across this to start with and see if the trend in the nearshore trawling from this data set matches or adds to the USGS. And what's interesting is, when I first looked at this, I thought I'd actually pulled the wrong data in the spreadsheet, that I was replotting the bottom trawl survey, because it was almost identical. These ups and downs, the peaks, and even the fish per meter squared estimate was relatively the same. And so when you look at the nearshore bottom trawling and you correlate that to the USGS, for an individual data point, it's a little bit higher, but it's not a lot higher. And then look at the R squared. So basically what this says is we could just expand the USGS bottom trawl to all depths, and that would give us a lake-wide estimate, which probably wouldn't be much more than a couple kilotons. However, let's add the Michigan DNR bottom trawl survey, and what you found is a different pattern. So I should have stopped at the Inland Seas. I don't know why I went forward with Michigan DNR data, but now it caused some problems. Why is the Michigan DNR data so different? Why is it so variable? And I don't have error bars in these trawls, and it is a little bit higher, but again, these are nearshore trawls, but at some point in time, the variation was just huge. 0, 0, 0, big catch. How do you explain that? Well, before I explain it, let me just say that there's no correlation in the USGS bottom trawl, suggesting that maybe we have to deal with the nearshore differently. But if we use the per meter squared, adjust it to kilograms per hectare, which is what the unit that the bottom trawl does, and expand that to our lake-wide estimate, if we added the Inland Seas data, we would add 4.4 kilotons. If we had the MDNR data, even though the trends don't match, we would add 5.1 kilotons. So, okay, now we're getting up 5 to 7 kilotons is goby abundance. Maybe this is the way to deal with it. But I'm still kind of bothered by the fact that this MDNR data, the trends didn't match and there was a lot of variation. Well, a trawl is conducted on soft sediment. You can't trawl rocky habitats. And so maybe, and then every once in a while we get 0, 0, 0. By the way, these are not jumping Asian carp. Okay? I was worried about that inside. This is our very technical way of counting gobies. When you encounter a trawl of 5,000 gobies in a trawl, you use shovels. But how do these nearshore trawls get these huge catches and then they'll get 0 catches? So what I'd like to do is show you a video. And I want to show you a video of a bottom trawl conducted on our boat. So let's go ahead and jump to that if we could. And we'll start the video with basically the bottom trawl leaving the boat. And I want you to note a couple things. One, at the beginning of the trawl, it's on soft sediment. But it's relatively shallow, so we're going to start to encounter mussel beds and rocky habitat. This is like 10 to 15 meters. And when we see that rocky, the other video, sorry. When we start to see that rocky habitat, you'll start to see gobies, which suggests to us the bottom trawl is characterizing goby abundance on soft sediment. But what we know is gobies prefer rocks. And so therefore, when you start to look at our trawl catches, maybe we're not characterizing gobies where the gobies like to live. That's one potential theory. So if we go ahead and play this, here's the bottom trawl leaving the boat. Hopefully no one gets seasick here in the room. And the GoPro camera is just mounted to the head rope. Go ahead and jump ahead. We'll just kind of make this go. So now we're in the water. The trawl is it's a bottom trawl, a small nearshore bottom trawl, and it's just going down. Go ahead and jump ahead a little bit. And what you're looking at is you're looking at the top of the trawl. Okay, see there's no real bottom here, so go ahead and jump. You can see it's soft sediment. Okay, now you start to see gobies showing up. And this is a trawl with 5,000 gobies that we caught. And what you can see is the bottom starts to get a little bit harder, and there's gobies. And there's not just a few. The entire bottom of the lake is covered with gobies. At this depth contour, at an interface between rocky habitats and soft sediment. So now it starts to give me a little bit of clue that maybe our trawls are indexing soft sediment gobies, but every once in a while, when you get close to a rocky habitat, look what you catch. So maybe, I mean, this is unbelievable, right? I mean, just unbelievable numbers of gobies. By the way, I also say, as we study some behavior of the gobies, typically fish will have a herding approach and a bottom trawl comes, they all kind of swim the direction of the trawl and they try to get out of it. The gobies almost seem to come to it sometimes, like what's going on. You also notice occasional dust piles popping up. Those are actually predators that we didn't catch in the trawl that sense the trawl and they leave. Smallmouth bass we've noticed, walleye we've noticed. See the soft sediment? No gobies. So the variation of the trawls and our ability to estimate lake-wide abundance might be how close we're sampling the rocky habitats and can we actually sample rocky habitats. So I think that's enough of the effect of bottom trawl. Let's go to a rocky habitat now and say, well, you can't trawl across rocks, but what can you do? Well, you can go ahead and stop the video, move to the next one. So what we designed there was we at first set passive traps, minnow traps on rocky habitats. And we found the same thing. No goby, 100 gobies in a trap. So we thought, okay, well, why don't we go ahead and just use the cameras to estimate, and a lot of people have done this before, estimate goby abundance. And how will this compare in a per square meter estimate to trawling on soft sediment, like the USGS bottom trawl or some of the other nearshore bottom trawls. So this is a rocky habitat, very shallow depth, about 6 to 10 feet. And what you're going to see is, you're going to see a tripod with a GoPro camera looking down in a minnow trap that we're hoping to catch the gobies in. And just to put in context, the bottom trawl estimates, when you put a number per square meter, were about 0.1 gobies per square meter in a bottom trawl. When we started looking at these nearshore habitats, now again, we would have big catches, but when you average those catches of the bottom trawls across the different habitat types, what we find is that the average would still in the nearshore trawls be 0.19 per square meter. So nothing like what we thought was existing in the rocky habitats. So here we have a rocky habitat, we have the GoPro camera, and here's the minnow trap, and you're looking down. So see if we can slide that over a little bit. Okay, and you can just let it play now. So we have the minnow trap, and if you look at this is less than a square meter, it's about a half square meter, and you've got goby. We're up somewhere around 20 per square meter right now. We'll also see rusty crayfish, but you can see, and you can't trawl across this habitat. So instead of 0.1 per square meter, we're looking somewhere like 20. Now here's our minnow trap, and we're expecting to catch some of these in these rocky habitats. And what you'll see is if we pull that trap up, we didn't catch a single goby. So suggesting to us that not only is the abundance in the nearshore habitats and these rocky habitats 100 to 200 times more abundant, but also without cameras or other technology, the ability to estimate goby abundance in these habitats are very challenging. But we have the estimates now. We have drop cameras and we have estimates on rocky habitats. So let's assume that the trawls sample gobies in soft sediment. The next challenge then is to here's an eggs per square meter. This is an egg bag measure. It's another measure of the rocky habitats like the camera drops. And it's the longest trend we have, but we're seeing 10 to 16 gobies per square meter. Let's apply these estimates for rocky habitats like Michigan and use the trawls for the soft sediment. Well, when we do that, here's a GIS layer of Lake Michigan, all the The black now is what we're going to call hard substrates. And first, let's start with the nearshore area, the area less than 5 meters. And let's apply a 10 per square meter estimate to those rocky habitats. Again, because these densities are much higher, a large proportion of the lake is rocky, and IFR provided this GIS analysis and layer, which is extremely helpful. Well, when we do that and we add the rocky habitats, our estimate of kilograms per hectare, this is based on that 10 per square meter, applied to the area of the rocky habitats, the biomass goes, you have to add another 21.5 kilotons. If you add it to the offshore rocky areas, assuming that the goby abundance, the 10 per square meter, is the same on rocky habitats, whether you're in 5 meters versus 50 meters, and you just apply it to the entire GS layer, now you better add another 951.3 kilotons. What I really like about data and the way things move is, like, it's always good to talk about bigger units, and we've been talking about prey fish in kilotons and how low prey fish abundance is going in Lake Michigan, and 2 kilotons. Now we're talking about megatons. We're getting up there. So if this shouldn't provoke discussion about how many prey fish are in Lake Michigan when you start talking about megatons, I don't know what will. Let me also say these estimates are based on some big assumptions. Assumptions that nearshore rocky habitats of 10 per square meter are the same as an offshore deep reef in terms of goby biomass and abundance. We don't know that, but we better measure it. It's also based on the assumption that these estimates of rocky areas from the GIS layer have been ground truthed, and we know that estimate. There could be a lot of variation in the amount of habitat. Not only that, hard substrates in Lake Michigan are actually changing. No, we're not dumping a bunch of rocks in the lake, but through dry sediment, zebra and quagga mussel colonization, soft sediment is becoming hard sediment. There's another way we could approach this, though. So maybe I'm way wrong saying that there's almost 1,000 kilotons of gobies in Lake Michigan. And that could be through a consumption approach. Taking all of the predators and looking at their consumption of round gobies and their biomass, and then estimating with consumption how many gobies are in Lake Michigan based on what they ate. So one thing I would like to conclude is, in order to prove me wrong, I think it's very important that maybe we do this. Maybe we look at a consumption-based approach. So in summary, what I would like to say is that the goby biomass and nearshore trawling is on soft sediment, and when you add nearshore rocky habitats, the total jumps to 28.6. It's adding in the USGS, the nearshore trawling, plus the nearshore camera drop estimates of how many gobies there are. If you were to assume the offshore rocky habitats were similar in abundance, huge biomass. But I really think the consumption approach is needed, and in Lake Huron, I believe this is an ongoing effort to actually try to do this with round gobies. The implications for the study, well, if you look at the USGS bottom trawl survey, or my estimate, maximum estimate of 1,000 kilotons, and we're uncertain whether it's between 2 and 1,000 kilotons, that becomes pretty important. Also, the fact that these nearshore areas are likely the source of goby production. And when they go into the offshore soft sediment, my guess is their consumption or their mortality rates go up dramatically. So you've got the source population producing a prey fish that once they get off in the soft sediment, they're being eaten by everything out there. And so that makes this patchy distribution very hard to estimate. And I think Chuck Medengian would agree the mortality rates around gobies are pretty high in Lake Michigan. Last implication. We always talk about the disruption in the food web and the disconnect between the pelagic zone and the benthic zone, the nearshore versus offshore fish production. What this analysis to me also suggests is that the gobies are providing this critical link between nearshore production and rocky habitats and offshore fish production. Understanding this link might be the key importance to managing not only nearshore fish communities but also offshore. So maybe gobies are the new alewife. And with that, I would say thank you very much. I really appreciate it, and if I went over, my apologies.